Hello, enthusiastic people. How are you doing? I hope all of you are fit and fine. So, this is again your physics instructor, Rishabh, and yeah, let's get going. By the way, before moving on, if you remember last live, I showed you something. I showed you a physics toy, and I asked you what is the principle on which this works. Let me get that thing for you. So, if you remember, this is what I showed you last time, right? This was the toy, and I asked you on what principle does this thing work. See, now the thing is that it's non-magnetic. There is no magnet attached. That's nothing. It's just pure metal. And when I'm keeping it on top of this thing, it vibrates. It moves around, but it does not fall. See, I'm gonna give you a push, give it a push, and see, it is not falling down. Okay, and that's very weird. Why is it not falling down? Because usually when you have things, placed in such a manner, and if you just push them a little bit, they will fall. This thing is not falling at all. What could be the reason? Okay, and the answer lies in the concept of center of mass and center of gravity. The thing is that, see, there are two masses here, right? These two masses, this is the place where majority of the mass is stored. Okay, this is mass m1, this is mass m2, both are same. So maximum amount of mass is at the two ends. Okay, and this person has its own mass. Now if you look at the combined mass, the total center of mass lies somewhere around here or somewhere little up. This is the point where the center of mass lies. Okay, the object falls when the center of mass moves away from this line. If the center of mass is, let's suppose, up around here, it will fall when it is unbalanced. If the center of mass is here, it will fall when it is unbalanced. But when the center of mass is right below the point where you are standing, where the person is standing, it will not fall. That's the reason we do not fall. When we are standing on the ground, we do not fall. Why? Because our center of mass is maintained when we are standing. Let's suppose this is us as a person. We are the person, we are holding the thing. Okay, with our legs, we are balancing the center of mass. We are making sure our center of mass lies in this line, on the line when I'm putting my foot. That is the line where we keep our center of mass, and that's why we do not fall. Now the center of mass is actually a huge topic. Okay, so let's keep that for some other day, but this was just to give you an idea. Okay, so yeah, let's begin with today's topic, shall we? All righty. Okay, let me share the screen with you. What I'll do is I'll do this, and yeah, let's go. So last time I believe we covered the time of flight, right? We calculated the time of flight of projectile motion. Now today we will cover how high the projectile will go. What is the maximum height achieved by the projectile? Let's have a look at it. So again, let's write projectile motion. Projectile motion. And let's call it as height of projectile. Height of projectile. Now, as usual, we will draw our projectile motion here. So let me write this here. That's your y-axis. Then we have our x-axis here. And then we're going to take a ball. Let's say this is our ball. And we're going to throw it with some velocity. Let's call it as u. U is the velocity with which I am throwing this ball. It's the initial velocity with which I'm throwing the ball. It will move like this, reach a maximum height, and it will fall down. Okay. This is the trajectory of projectile. This is the trajectory of projectile. But what do we want to calculate? We want to calculate the maximum height. So when this ball is moving through this path, this is the point. We want to find this height h. Oh, by the way, this shape that you're looking at, this shape is called as, do you know the name of the shape? It's called as a parabola. Okay, it is called as a parabola, which is usually given by a general equation of parabola is y is equal to 4 ax square. There are multiple equations, multiple ways you can in which you can write this thing, but yeah, that's a general equation. Okay, anyways, so we want to find the height of this projectile. Now how do we do that? Now think, I have told you that whenever you are solving anything related to projectile motion or any two-dimensional motion, our first job is to break the problem into x directional motion and y directional motion, and that is exactly what we're going to do here. Let's give it a try. So I will have this initial velocity u, and I have launched it at an angle theta. What I can do is I can break this velocity into two components. What are the two components? One along the x component, I will call it as ux, which is u cos theta. U refers to initial velocity, v refers to final velocity. Okay, that's the notation I use. And uy would be u sine theta. Now, for those who do not remember, go back to my previous slide where I have explained how a vector can be broken down into two perpendicular components. Okay, so this vector u can be broken down into ux and uy. Now, how am I going to use this? There is very simple way to use this particular thing. Okay. If you remember, there was one kinematical equation which was like this. Actually, let me write all the three. So the three kinematical equation that we have, general KE. Okay, I'm just writing general KE and we'll be using them for x and y separately whenever needed. So we had v is equal to u plus at. That's one. We have delta x is equal to delta x or delta y, depending on x axis or y axis, is equal to ut plus 1/2 at squared, and you have v squared is equal to u squared plus 2a delta x. Okay, again, delta x or delta y, whatever the direction that you're referring to. Now, when it is at this height, what is happening to the velocity? If you observe it there, you will see this velocity will still remain u cos theta because there is no acceleration along x direction. So if there is no acceleration along x direction, there will be no change in the horizontal velocity, but the vertical velocity changes. If you remember last session, I have showed you something like this, that when this particle moves up from here to here until this point, its velocity changes in such a way. So x remains same. X will be your u cos theta all the time. U cos theta, u cos theta, but the y velocity keeps on decreasing. You will have Vy, which is little less. Then you have Vy even lesser. See, the smaller the arrow, the smaller will be the magnitude. And here Vy simply becomes equal to 0. So at maximum height, the final velocity is 0. So we have that point at max height. V final is equal to, or let's not call it as V final, let's just call it as V equal to 0, because V final is V. And initial velocity we know, V final along y is 0, and initial velocity along y was u sine theta. What is acceleration along y direction? Acceleration along y direction is negative g. What is the displacement here? Displacement along y is the height. That is what we're trying to find. Now, how can we use these four terms to get the value of h? If you observe equation number 3, you have v squared is equal to u squared plus 2a delta y. Final velocity, this is y, and this is also y. Final velocity along y direction becomes 0. See, at this point, velocity is becoming 0. So velocity is 0. What is the initial velocity along y direction? That is your uy. Uy is u sine theta. So u sine theta and square of the whole thing plus 2 times acceleration along y direction. What is acceleration along y direction? Gravity is pulling it down. So minus g and delta y. Delta y refers to the height h. Can we find h from here? Yes, of course we can. If we rearrange this equation, I can write it as 2gh is equal to u square sine square theta, and h can be written as u square sine square theta over 2g. That is the formula to calculate height of the projectile, maximum height of the projectile. I hope that is clear to you. Yes. All right. If that is clear to you, then we can move to the next part. Let's try an example. Okay. So let me give you an example. Let's try the example. Oh, I gave you homework last time. How many of you were able to solve this one? Comment if you were able to solve this one. Okay. And at the end of this session, I'll give you the solution. Let's try this one. I think we did some. Oh, did we do we not have that? Okay, anyways, I'll use, okay, see, this is the example that we did, that we threw something with some velocity. Initial velocity was 9.8 meter per second. Let's actually, make our own example this time. So we are gonna throw something. Let's hope that something is not you. Of course, we'll not throw you. Let's take a ball and let's throw it. Let me see that so that I can make the calculation a little easier. Let's take U as 10. This theta is 30 degree. Okay, you're throwing it at an angle of 30 degree with the speed of 10 meter per second. It's gonna go to a maximum height and then it will fall down. This is what you're trying to find, h. Now h, we just calculated the formula. It is u square sine square theta by 2g. Now you don't have to remember this formula. You just need to know how to derive this. So every time you have a question, you will simply follow this procedure, derive the equation, and then u square sine square theta over 2g. Do not memorize the formula. It's of no use. Trust me, it is of no use. Okay. Even if you would memorize it, it will be helpful 1 or 2 times, but eventually you're gonna forget. Okay, if you don't do it if you don't repeat it continuously. So it's better to know how to solve this logically rather than memorizing stuff. Okay, anyways. So height is equal to initial velocity is 10, square of that, sine square of theta 30. Sine square of 30 divided by 2 times. Let's take G as 10. We are approximating G is 9.8. But we are 9.81. We are approximately considering it to be 10 meter per second squared. Okay. So it becomes 100 times sine square theta. Sine 30 is 1 by 2. Square of that. Okay. And divided by 2 into 10. So I can get rid of this. And what I'll have is 10 divided by 2 multiplied by 1 by 4. So I'm going to get 10 divided by 8. How much would that be? That would be 1.20. So 1.2. And let's see, do we have 4? So that would be 5, 1.25. All right. Meters. That is the height that it's gonna go, 1.25 meter high. I hope that is making sense. All right. Okay, now as promised, I'll show you the solution of this one. Okay, I'll give you an intuition to solve this one, and then you can, try the mathematics for it. Okay, this is the intuition that when you throw something, okay, both of them are falling under the action of gravity. This is going to fall under the action of gravity. This ball, which let's suppose it is here, this is also falling under the action of gravity. What will happen? No matter what the speed is, whatever the speed is, the object will always hit this ball B if you are throwing it with enough speed so that it will at least reach here. So our next topic is basically range of the projectile. So you should throw this ball with enough speed that it should at least reach here, no matter what the angle is. It should, even if it reaches here, if you throw it with some higher speed, even if it reaches here with, if you throw it with some or more higher speed, in all the scenarios, it will always hit the ball B because you have thrown it at an angle which was directly pointing to B. So let's suppose if you have thrown it here with a very high velocity. So in that case, it will move this path and this ball B will reach there and the ball A will hit it here. Or if you're throwing it little slower or at some different angle, okay, in that case, ball B will reach here and ball A will hit it here. So on and so forth. So I hope you get the idea. I hope you got the idea basically. All right. So yeah, that is the whole idea behind this particular problem. So give it a try. Try to identify the mathematics behind this, and yeah, comment down your answers. What mathematics that you used. All right. So I think yeah, we learned height of the projectile today. In the next session, we will be learning range of projectile. So yeah, that's it for today. I will see you in the next one. Until